Hello everyone, good evening. This is Sangeetha, Assistant Professor, EC Department, SNS College of Engineering. So in the last video, we discussed about wavelet coding. Let us let us have a small recap of wavelet coding. So wavelet coding is a multi-resolution analysis and ability to avoid blocking artifacts, make it an advanced and versatile method for high quality image and video compression. So it is particularly used in professional and critical applications. So in this video, we are going to see the run length coding. So images with repeating intensities along their rows or columns can often compressed, representing the runs of identical intensities as run length pairs, where each run length pair specifies the start of a new intensity and the number of consecutive pixels that have the intensity. So the technique referred to as run length encoding was developed in the year 1950 and became along with its 2D extensions. The standard compression approach in FAS. So compression is achieved by eliminating a simple form of spatial redundancy and a groups of identical intensities. So when there are few runs on identical pixels, run length encoding results in data expansion. So run length encoding is simple lossless data compression technique that reduces the size of data by representing consecutive identical values. So in RLC, instead of storing each pixel's value repeatedly, we can store the value and how many times it appears consecutively, that is the length of the run. So this reduces the overall data size when there are long sequences of the same pixels. And the basic idea is to code each continuous group or once encountered in a left to a right span of row by its length and to establish the convention for determining the value of the run. So the most common conventional or to specify the value of the first run of each row or to assume that each row begins with a white run whose run length may in fact be 0. So let us have a small example. So consider this example 5 cross 5 binary image matrix. So the matrix values are in the first row all are 0 and the second row first 3 columns are 0 and the others are 1 and then third, fourth, fifth rows are containing only zeros. So here the 0 and 1 are the pixel values. Using run length coding, we will scan each row from left to right and encode the consecutive pixel values as a runs. So in the first row, there is a run of 5 zeros. So the RLC output is 0, 5. And in the second row, there are 3 zeros followed by 2 ones. So the RLC output are 0, 3 and 1, 2 in the second row. And in the third row, so there is a run of 5 ones. So the RLC output are 1, 5. And in the fourth row, another run of 5 ones. So the RLC output same as 1, 5 and also similarly the fifth row, the RLC output is 1, 5. So the complete RLC output for the 5 cross 5 image or row 1 0, 5, row 2 0, 3 and 1, 2 and in the third row 1, 5 and fourth row 1, 5 and fifth row also 1, 5. So the entire image can be represented using the run length coding. So in this, so there are number of factors are 6 and maximum length is 5 and number of bytes per pixel is 1 and total number of pixels are 6 into 3 plus 1, that is 24. So the number of pixels for original image is 5 into 5, that is 25. So the reduction ratio is done. So the compression ratio, the formula for compression ratio is number of bits in the original image divided by the number of bits in the image after reduced. That is in the original image, the number of bits in the original image is 25 and number of bits in the image is after the reduction is 24, that is 25 by 24 is 1.042. the compression ratio is 1. And so in the first case we are dealing the pixels as horizontal wise, and in the second case the same but vertical wise. So the run length of first row is 0, 2 and 1, 3, and the second row is 0, 2, 1, 3, and third row 0, 2, 1, 3, and 0 in the fourth and fifth rows are 0, 1 and 1, 4. So the number of vectors, total vectors are 10, and maximum length, that is width, is 4, and number of pixels are 1. So the total number of pixels is pixels 10 into 2 plus 1, that is 30. So the first, that is horizontal wise protection, is advantageous than the vertical wise. So in this case, instead of storing 25 pixel values, we only store the pixel value and the length of each run. So the RLC representation uses just 12 pairs of values, which results in a reduction in data size, especially for images with large areas of homogeneous pixels. So the RLC works best when there are long runs of the same value. However, for images with a lot of variation, RLC might not be as effective since the runs would be short. So the main advantages of run length coding are simple and easy to implement. So the algorithm is straightforward, making it computationally inexpensive and good for images with large homogeneous areas. That is, the RLC works efficiently for images with long runs of the same pixel values, and it is mainly used for lossless compression. That is, no data is lost during compression, so it can be perfectly reconstructed. So the main disadvantages are not efficient for complex images. For images with a lot of variation, that is for example natural images, the RLC may not provide much compression and could even increase the file size. And the next disadvantage is limited use cases, that is, it is best suited for images with repetitive pixel patterns, that for example simple black and white images only it can be suitable. So overall, run length coding is an effective and simple method for compressing images with large homogeneous areas. Like the example, it reduces storage by representing consecutive identical pixels with the pixel value and length of the run. Hope this video will be helpful to understand the basics of run length coding. Thank you.